All right, this is a video of me going through the first of the 2 pages of 8.1 Principles of Counting, and we're more in the next, when we actually have our next class, we'll talk about specific type of problems, which are called permutations and combinations. But for now, and some of these that we'll touch on here are that, but we're not going to put it into that category. But it is important when going through problems, as we're going to see, to figure out, all right, are we talking about, does an ordering of something matter, or does it just matter which 3 things we get in a particular group, or however many things we're talking about? So let's do this first problem. And there's a visual to help you out. And it says there is a road map between 4 villages, and the arrows represent directional roads. And so how many distinct paths are there from A to D? And so you could either go to the left or the right here. So if we talk about going, let's go from A to C to D. Well, from A to C, there are 4 paths. And for each of that paths taken, I could take 3 other paths from C to D. So that's why when we're going from A to D, I can have 4 times 3. So that's one way. That's this way here, how many different paths there could be. Or I could go the other way. So whenever you think one way or the other way, or means plus. So then from A to B, there's 2 ways. And for each of those ways, I have 4 options to go from B to D. So I'm going to multiply by 4. So the total number of paths there would be 20. Okay, so a typical counting problem often has to do with words or letters. So on the island of Mumble, the Mumblean alphabet has only 5 letters, and every word in the Mumblean language has no more than 3 letters in it. Okay, so you're either going to have a 1-letter word, a 2-letter word, or a 3-letter word. So or remember means plus. So let's do, we've got our 1-letter word, or 2-letter words, or 3-letter words. And notice when we're talking about words or occupying particular positions, I like to kind of create these particular spots or these lines here. So for the 1 word, and notice, again, the alphabet has only 5 letters, and each word can have a repeat of letters. So for the 1-letter word, there are 5 possibilities because it could be any of the 5 letters in the alphabet. 2-letter words, there could be 5 possibilities for the first letter and 5 possibilities for the second letter. And then for the 3-letter words, again, 5 possibilities because we can have repeats here. So this would be 5, this would be 25, and this would be 125. So adding it all up, there are 155 different words. Okay, another kind of typical thing that you've probably talked about when you did this in middle school is different number of different outfits. So 4 clean pairs of jeans, 5 clean shirts, and 2 different pairs of tennis shoes. How many different jean, shirt, tennis shoe combinations does Roxy have? This is very similar to the path problem because for each pair of jeans, there's 4 different pairs. I can have a choice of 5 different shirts to go with each of those. So times 5 and then 2 different pairs of shoes. So there's 40 total outfits. Okay, now next page here. So now we're getting a little bit more complicated. So there are 19 students and 1 teacher. Everyone, including the teacher, shakes everyone else's hand exactly once. How many handshakes take place? Okay, so there's a few different ways to think about it. One way to think about it, okay, the first person has 19 people they shake hands. But then since they've shook the hand of somebody else, then the next person only has 18 people, then 17 people, and so on, all the way down to 1. So that's one way to think about it. And which you'll learn over the summer, which normally we would have done by now, is called an arithmetic sequence, but not there yet. So I think another way to think about it is how many pairs of people can we have? Because when you're shaking hands, you're thinking of pairs. And the key is order doesn't matter. So me shaking Joe's hand is the same as Joe shaking my hand. So I have to divide out the order. So if I think about, okay, there's how many ways can I select 2 people? Well, there are 20 people for the first, and then if one person's selected, then there's 19 left, but I have to divide out the number of ways to order those things. So I'm going to divide that by 2. So in other words, there are 190 different handshakes. You'll notice some of the names, and I meant to change this to you guys. This is last year's class. Alex, JP, Arnav, and Roland are playing poker. Alex starts to deal 5-card hands to each of his friends. JP receives 2 cards and exclaims, "Oh, there are how many possible 2 cards hands?" Okay, so there are 52 cards in a deck. And how many ways can the first card be dealt? Well, 52 ways. And then, well, 1 card has already been dealt, so then there are 51 ways to deal the second card. But again, order doesn't matter. The order of the cards in my hand doesn't matter, so I have to divide by the number of ways of ordering those 2 things. Here, we're getting to some ordering problems where order does matter. We're talking about sitting side by side, left to right. So CEM, notice is different than CME. So you want to count out and list out how many different ways can these 3 people sit together side by side at the movies. And so once you lift out the ways, another way to think about it, here's the first spot, second spot, third spot. How many ways can I fill the first spot? Well, there's 3 people, so there's 3 ways to fill that spot. And then someone's taken up a spot, so now there's only 2 ways to fill the next spot. That person's taken away, and now there's only 1 way to fill the third spot. So that's 6 different ways. And then you can do the same for 7. So this time there's 4 spots. So, and there's 4 people I'm choosing from. So 4 ways to fill the first, 3, 2, and then 1. And so that's 24 ways.